Yeah, apparently I read it. I like it. I see it.
Okay, is everybody doing okay? You had a good weekend? Okay. Anybody has any questions on what we did last time? Okay. So last time I think this is the last example we did. We asked how many different 7-place license plates are possible if the first 3 places are to be occupied by letters and the final 4 by digits. And the answer that we came up with was 26 times 26 times 26, 10 times 10 times 10 times 10, whatever that number is. Now let me ask you this. You guys use a smartphone or a cell phone. You have, you use a 4-digit or so password for your cell phone. Is that right? So how many possible passwords how many passwords are possible if you are only using digits? 10 to the 4, right? Okay, which is about what? Which is what? 10 to the 4 is the same as 10,000, yes. Okay, so and then we said, what if we change our question a little bit? And same question as before, how many license plates would be possible if repetition among letters or numbers were prohibited? Well, in that case, the first 3 are letters. So for the first letter, I have 26 choices. For the second letter, I have 25 choices. For the third, I have 24 choices, right? Because you want distinct letters now. And then we pick digits. So for the first digit, I have 10 choices. Once I pick the first digit, then I have only 9 more choices available for the next digit, and then 8, and then 7. So go ahead and compute that, and whatever you get, that's the answer for that question. Are we okay with that? Everybody is okay with that? All right, so let's look at the next question then. How many functions defined on n points are possible if each functional value is either 0 or 1? When I teach stat 1561 sometimes, I can't ask this question because there are lots of students who may not know what a function is in that class, but you guys are all engineers, so you guys know what a function is. So how many functions defined on n points are possible if each functional value is either 0 or 1? What is a function? Function is an input-output process, right? With some special property, right? Now, you can think of a function on n points with values 0 or 1 as a bit string, right? If you are in computer science, right, you have seen bit string, right? So bits mean, what is a bit? A bit is 0 or 1, right? On or off, right? So you can think of such a function as a bit string because you're going to write down the values of the function 0 or 1 for each input, right? So if you look at the picture that I have of a bit string, so it'll be an n-bit string, right? If you write out all the values of the function, right, you're going to get an n-bit string, right? Is that making sense? So in that sense, I'm basically asking how many n-bit strings are there? How many n-bit strings are there, right? Isn't the question the same? Let's look at a specific case when n is 8. When n is 8, let's say the input points are A1, A2, A3, A8. Right? Those are the inputs. And the output, f of x, will be 0 or 1, right? So I have an example of one such function, right? There are many other possibilities here. So this is a function when n is, this is a function on 8 input points where the value of the function is either 0 or 1, right? Is everybody clear? Okay, so think about this then. So I want to know how many functions are there on n points where each of the values of the function is either 0 or 1, right? So imagine that I have n points, right? So I probably should put dot 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 here. Big dots are the inputs, okay? Okay, so for the first input, how many choices do I have for the output? The output has to be 0 or 1, right? So I have exactly 2 choices for the output of the first input point. For the second input point, same thing, right? These are the choices, right? 0 or 1. 0 or 1. So for each input, the possible outputs are either 0 or 1. So now the question is, how many such functions are there? Yeah. If I have 8 points, if I have n points, it's 2 to the n, right? So notice that for the first input, I have two possible output values. For the second input, I also have 2 possible output values. For the third point, I also have 2 possible output values. And for the last point, I also have 2 possible output values. Is that making sense? So you can think of it, experiment 1, pick an output for the first point. Experiment 2, pick an output for the second point. Experiment 3, pick an output for the third point, and so on. So each of these experiments has 2 possible outcomes, right? So together, by the multiplication rule, we have 2 to the n possible outcomes, right? So the number of functions here would be 2 to the n. Does that make sense? It's the, so for, let's say I have 8, n is 8, right? So if n is 8, so I have 1, 2, 3, 4, 5, 6, 7, 8. How many 8-bit strings can I write down? Anybody in computer science? How many 8-bit strings can I write down? Yeah, 2 to the 8, right? Because I'm trying to write down an 8-bit string. Okay, an 8-bit string means I have 8 bits. Remember, a bit is 0 or 1. So for the first bit here, I have 2 choices. For the second bit, I also have 2 choices. For the third, I also have 2 choices. And so on for each of the bits, right? So because I have 2 choices for each bit, I have 2 to the 8 possible n-bit strings, right? That's exactly the same as the number of functions on 8 points, where each value of the function is either 0 or 1. Am I making sense? Any questions, anybody? No? All right.